Hello, and welcome to Aerospace Testing International's roundtable on flight testing, meeting the quality challenge for flight test data in aircraft development and certification. Flight testing is one of the most complex and technically interesting areas that we cover. It's unique to the aerospace industry and provides its own set of engineering challenges. It's often seen as expensive and time-consuming. The technology it uses is always evolving to meet the needs of the industry. Today's webinar will aim to provide information and advice about how to deal with the challenges of a flight test program may pose, while keeping what is the ultimate goal in mind, the production of useful, reliable, and accurate data. It's a very big topic, and we're going to cover as much as we can in the hour that we have, from decision-making and project management to DAX, hardware-in-the-loop testing, and future technology. So to help us do that, we're lucky to have with us a couple of experts who will provide the benefit of their experience and knowledge. With us today is Erik Goethert, a Senior Director of Business Development and Strategic Marketing at United Electronic Industries, also known as UEI. Erik has designed, managed, and implemented many projects that collect real-world data for the aerospace, energy, and defense industries so that they can build smart systems that are reliable, flexible, and rugged. He has more than 30 years of experience in industry-wide hardware, software, and I/O application solutions. He has an engineering degree from Cornell University. We also have with us today Tom Bisges, Vice President of Bombardier Aviation's Flight Test Center and Specialized Aircraft Design. The Aviation Flight Test Center is based out of Wichita, Kansas. Tom is responsible for multidisciplinary functions consisting of program management, engineering, manufacturing, maintenance, and testing. The organization supports cradle-to-grave aircraft certification with multi-million-dollar budgets, all the time ensuring safety is a top priority. Tom also has 30 years experience in the aerospace sector, and for almost half of that time, he has held the position of Vice President, providing oversight and leadership for several aircraft platforms. So first of all, over to you, Erik. You're joining us by good old-fashioned telephone. I know. Oh, now I can see you, which is great. But would you like to just give a brief introduction to UEI and what your company does?
I would certainly. Thank you, Ben. I've got some slides here. I believe I can show. Hopefully you can all see them. Again, I am Erik Goethert from UEI. We do data acquisition and control hardware for flight tests, as well as ground support and hardware in the loop, software in the loop testing. Whether it's on the plane or on the ground or in the lab, we've got the avionics, the I/O, and the hardware that you'll see is the same, whether it is in the various different form factors. We are built to be flying, we are built to be on the ground, we are built to be on the flight line. And of course, we do have a 10-year availability guarantee to mitigate any of your obsolescence concerns, which I know can get pretty big in these industries, in these long-running industries. Thanks, Ben.
Tom, do you want to talk us through Bombardier and some of the capabilities in flight tests that you've got? I mean, you've got a video to show us and everything.
Yeah, good morning. At least in Wichita, Kansas, it's morning. So I appreciate the opportunity to meet with everyone today. Love starting out with a little video to show some of our more interesting testing. So let me start with. second here. So the Bombardier Flight Test Services and Specialized Aircraft is a unique activity inside of Bombardier. We support all the Bombardier product lines, and then we also provide the design services with respect to the missionized airplane projects. Over the years, we've actually supported over 30 different aircraft programs, some of them derivatives, many clean sheet programs. So we're an integral part of the design process in Bombardier. We start at the very beginning of the program in integrating, defining the requirements for testing, and proceeding through that activity to support those programs. So we're a member of the new product development team and partner with our engineering teams to support those end products, which is delivering data to support certification. Within the world that we support, we also have a cradle-to-grave capability that involves certifying missionized airplanes and STCing the shapes. We have our own repair stations. We have quality systems approved throughout with Transport Canada and also with the FAA. And we work closely with those institutions. We can design, build production parts, install, find compliance through the test data and the certification. Truly a cradle-to-grave operation that we maintain. It's very novel and interesting. We have lots of unique products that we pursue. So all in all, it's been an interesting 30 programs. I'll give it back to you, Ben.
Great. Thanks for that, Tom. So just really quickly, a reminder about the format before we start. While Tom, Erik, and myself are talking, I'd encourage you to ask questions. These can be submitted using the panel you should see on your screen. We'll then go through those questions in the second half of the webinar. The rest of the audience won't be able to see those questions until they've been asked. I'd also like to remind everyone at this point that this is a technical discussion about flight testing. So questions about financial matters or details about projects aren't really what this is about. So finally, just one last quick thing. You should see a poll once I've published it for you all to answer while we're talking as well. We'll discuss the results of that later. So yeah, onto the question and answer part. Tom, you're going to start us off, and I thought we'd pay our respects to the title of the webinar by talking about data. I mean, data's so important in so many different parts of what we do now, especially in business and industry. I mean, how much does the need to produce high quality, reliable data influence and shape what you do in flight testing now? I mean, does it matter more than it used to?
Absolutely. Historically, you know, there was a point in time where you'd certify airplanes literally with knee pad information. So with the onset of technology and the ability to record data, it's progressively increased in the expectations for the high fidelity and precision data and information. Increased number of quantity certainly over the years. With that, you embrace new technology and provide that. Aircraft time is precious. So ensuring that you provide adequate design and installation of data before you even fly the airplanes that we test is one way to protect schedule and ensure that you're going to get an output. Data is the primary deliverable that we utilize to show compliance to the regulatory authorities, and the need to provide ever increasing amounts is always on an upward trend.
And there's more data now than there ever has been before. We've always been told it's growing and growing, the amount that
absolutely. So we've gone from megabytes, gigabytes to terabytes with respect to data. We have to realize the more complex and integrated airplanes become, the more important it is to record, even for purposes of diagnostic capabilities, to understand the airplanes. Our Global 7500 that we went through a recent certification, certainly relied upon the rigs and the simulations, but ultimately the expectation still exists that you go out and collect the data on the airplane and demonstrate it through those means.
Okay. Erik, I mean, very much the bread and butter of what you do, is it? data.
Yeah, correct. And we are also seeing, more demand for higher fidelity, larger systems to acquire more data faster, and obviously to be able to replay it back on the ground.
Yeah. Okay. So, Erik, I mean, what new technology trends in aviation do you think are impacting testing the most? I mean, what challenges do these does technology trends, do these new trends pose you, and how are you dealing with them? Can you talk around that for me?
Yeah, well, thank you. That's a great question. Aside from the smaller vehicles running on batteries, I like to focus on the modernization of the existing mature airframers. We see new interfaces, new methods of verification and validation of systems within the aircraft. Some of our customers are virtualizing the ground test and validation so that the hardware does not need to be in one bench or sill. Others are taking the hardware from the sill or hill and then flying with it, moving it straight from validation to flight. With the new interfaces and new methods comes new support hardware and software connectors. TSN, TTE, Firewire are some quick examples. New software connectors include stuff like VHTNG, Vistas, IDDS. We at UEI are working with the airframe manufacturers, system integrators, and industry groups to ensure that we have the hardware capability as well as the software connectors to enable these systems, to enable all this data collection. Okay, I mean, Tom, is there any technologies that you think have really impacted what you're doing now? I mean, I guess you need a time scale, but I'm thinking within the sort of last 5-10 years, I guess.
Yeah, certainly within the last 5-10 years, high-speed video, high-resolution video has become ever increasing expectations for post-flight analysis and capabilities to review and diagnose information. Also, with the onset of fly-by-wire systems, not necessarily recent, but the ability for us to integrate with the fly-by-wire systems with the experimental systems to facilitate some of the testing and drive failure case testing. So malfunctions testing is a key component also.
Okay. I mean, how do you begin to cope with those kind of new technologies within a project? I mean, do you kind of scope out what your unknown unknowns? Is that an exercise that you do, or?
Well, we have a pretty rigorous process that we go through after each program is concluded. Doing 30 programs, there's ample opportunity from a lessons learned standpoint. So we diagnose from the end of those previous programs. We look at new technologies and to solve those lessons learned, track and analyze and follow up to ensure that each program that we launch is going to integrate the newer technology, keep the good, improve the things you can improve, and always in the interest of retaining safe operations and quality data to ensure that you test once and you get what you need and then move on to the next project.
So is that part of the process of deciding within your flight test center about what equipment and systems and even expertise and skill sets you're going to invest in?
Yeah, those lessons learned play an integral role with respect to how we proceed, where we invest with the training, and where we apply our resources and in pursuits of new technology to address ever-increasing expectations for the production of the data.
Erik, is that an exercise that you guys, do you work closely with clients to help make that happen? That kind of making sure there's a roll on with the programs, that they've got the right equipment, because quite often people are using the same equipment again and again, right?
Certainly, but we're also seeing changes. For instance, Ethernet is becoming much more ubiquitous. Referring to those high-speed video cameras, all that data has to be moved and has to be saved and then has to be moved onto the ground. We're also seeing many customers of ours in the prototyping stage taking their hardware out of the hill, off the ground, and actually flying with it. So they're taking our hardware, testing all kinds of scenarios on the ground, and then taking up and actually using it to fly and testing it in flight to verify those models. We're seeing, all these models becoming much more higher fidelity, and so they want to iterate over their designs. In fact, there was just an industry day with the U.S. Army Futures Command this past Tuesday, and they're looking for partners for this exact scenario. The ability to iterate quickly without having to use separate hardware and software, will be quite the game changer. So tightly integrating the hardware between the ground and the flight test is helping some of our customers move quickly and efficiently.
So that to you is where the biggest change has been and is going to be within the next 5 years. This integration of hardware and simulation and software that really just speeds everything up a lot.
Correct. Again, we're seeing much more testing on the ground, much more failure mode testing, to Tom's point, to make sure that they can get through and safely fly. Flight time, as Tom indicated, is precious. It's much easier to crash a sim than it is, obviously, you don't want to crash an airplane.
Yeah, right. Yeah, okay. Is there anything else that you're dealing with at the moment that you think is going to make a big impact within the next sort of 5-10 years within testing itself? I mean, any new tech or? Yeah,
sure. Well, we're seeing a lot more wireless interfaces. And so as those become much more robust and much fatter pipes, so to speak, much of that data can be moved without having to keep it up. And we're also seeing, obviously, the electronics get smaller. So stuff gets lighter. Sensors can become wireless. All of a sudden, you reduce your weight, you reduce your wiring. Hopefully, all the data gets better as well.
Are you using wireless on the ground as well, or just with flight testing?
We see it both, because we see our customers want to reuse the hardware.
Okay. All right. Tom, I'm going to ask you that as well. I mean, what are you guys using wireless data networks and instrumentation to what extent?
Yeah, we use some Bluetooth technology. We certainly do a lot of telemetry work that we assist in minimizing crew for some of the high-risk testing to monitor more from a telemetry room. It's interesting, from a new technology standpoint, we are now competing for that bandwidth that we historically have used. So we're now investigating things like utilizing those different bandwidths that are available to support those telemetry transmitting and receiving requirements in flight testing.
But wireless isn't always the best way, right? That's what I've heard before.
Wireless on an airplane, it would be wonderful to believe that you could do Bluetooth all over the airplane and put in mini installations. There is some uses for that. As the data tends to expand with respect to the how much bandwidth it absorbs, it's going to be difficult to maintain a capability from a Bluetooth. But telemetry has been utilized years. From a safety standpoint, I believe that still will be a staple to be able to support and ensure minimal crew sometimes, like I said, are on board, but still have the go, no-go capabilities from a room of engineers to monitor and support testings. Again, emphasizing safety.
And just to go back, we'll stay with you, Tom, just for a moment, but just to go back to what Erik was saying about simulation and faster and faster design iterations, development times. Is that something that you're seeing in what Bombardier does as well, and your flight test center?
Yeah, for years we've utilized what we define as a SITS rig, a Systems Integrated Test Stand. It's primarily around an avionics capability. With the use of fly-by-wire, we've stepped it up with fixed-base simulators. We utilize these ground rigs for every test we do. On our 75 program, we flew many, many more hours than all our flight test airplanes combined in demonstrating and ensuring the test was ready to go. You do that from a test integrity standpoint and a safety standpoint. Our goal is to know exactly what the results are going to be before we go demonstrate it. So these rigs, we collect that data and information and do a high level of validation, again, so that when we go fly it, we already know what's going to happen and we've got an understanding of the expectation.
And if someone was to come to you now and want an aircraft tested and put through certification, that's the process that you'd very much follow, right? The emphasis would be on the bit before you get up in the air.
Yeah, everything starts with planning, and in the planning for the rig testings, the demonstration before you ever go fly the airplane is a staple.
Okay, so what do you think is, what's the kind of common mistake that's made with flight test programs? I mean, presumably you've made a few and you've seen a few been made. Is there?
So from our standpoint, sorry, go ahead.
Sorry, I was just saying, mistake's the wrong word, challenge I should use. If you don't want to talk about mistakes.
Is that a question for me, Ben?
Yeah, go ahead, Tom, and then I'll ask the same to Erik. Yeah, if Erik could talk to it.
Well, the typical mistake is when you enter into something new, a novelty or something you haven't historically done. Mm-hmm. So we like to focus on those particular pursuits, whether you're using new equipment or slightly changing and pursuing a new regulation. It's so important to put in place all the planning and all the preparation, almost to an ad nauseum level, because it's always better to do things once as opposed to twice because you had to circle back. So the typical mistake is to not properly identify those novelties that may appear with those new tests or new technologies. Okay.
Erik, I mean, you must work pretty closely. With your clients, I mean, do they always want the newest thing, or do you sometimes have to say, hey, calm down, let's get with what's reliable here?
Well, I think there's a little of both, and it depends on the age of the airframer, to be honest. One of the mistakes that we see is more of making sure you're identifying all the failure modes across all the different systems, and making sure that you've got hardware there to accurately exercise those different outliers. We've certainly seen many different systems fail in the field. That is the worst possible case. You want them to fail in the sim, on the ground, in your hill, so that when you get up, you're just showing that, yes, we have seen this failure and look, and we've got it handled. So.
Okay. I mean, you mentioned before about how you see ground testing and flight testing integrate, how it's important. I mean, could you give me a little bit more detail on that? I mean, how exactly is that changing? I mean, is it changing how you work quite a lot?
If you're asking me how we work,
well, I'm asking
because we are a supplier to all these ground test and flight test people. Mm-hmm. So we don't physically carry out the flight test. Sure. We supply the hardware and ensure that the hardware and software connectors are there so they can get their job done.
But I mean, you mentioned before about the way that ground testing and flight testing is integrating more so than before in the past. I mean, how is that changing? How are you seeing it change?
Oh, sure. Well, like I said, one of the things that we're seeing with a couple different customers is they're actually taking our hardware, which is not necessarily meant to be a flight control computer, and actually flying it. Taking the different simulations that are running on us and bringing it up and flying it just to ensure it works. And then they would go to, a full-fledged flight control computer, as opposed to using our kind of COTS easy prototyping hardware.
Okay, sure. Okay, so I mean, this idea that we're doing more and more on the ground and in simulation. I mean, the real driver behind that is the pressure to do more with less all the time. I mean, Tom, is this the primary way that aircraft manufacturers are dealing with that pressure or are there other ways of dealing with that time? Having to get something to market quickly but still do it safely.
Well, everything always starts with being safe. One way to be safe is to ensure that you have a high level of certainty and first-time quality and execution. So we look to provide automated capabilities, whether it's in the data reduction area or in road projects or activities that occur, to try and at least improve the capability of those activities that are done continuously. Create macros and tools which allow the engineers and the individuals to operate and focus more on the high value activities as opposed to some of the more redundant activities that are still there and appropriate. Everything starts with a good plan, and ensuring that you focus on that plan and you maintain quality of what you're doing. It's fine to do more with less, but you'll end up doing less with more if you don't instill and ensure the quality and the integrity of your testing and your planning and your pursuit is maintained. Again, it's always we seem to always find money to do things twice, but struggle with doing them right the first time. The reality is doing them right, planning correctly, keeping quality as a focus will ultimately be the way that it's done most efficiently and with the best economics. Okay,
sure. I mean, when you're doing a flight test, when you're planning a flight test program, and we talked a little bit about new technology in aircraft, technologies on the aircraft. I mean, you ever have to innovate within the testing technology and that you're employing itself and processes? I mean, does that happen? And do you encourage that?
Do I encourage it? No, but it's a reality of what happens if you've fallen down with pursuing the new technologies or the new support to certain certifications and tests. You have to be able to diagnose and respond to how that technology is either deployed and what the data is telling you. Understanding the data output and how you interrogate that and what the result is sometimes is that novelty involved in the hardware or the test itself can cause you to have to reassess and to correct. Maybe it's software, maybe it's introduction of slightly different hardware that was unforeseen. So we have to do those things sometimes. We adapt and we respond and we proceed accordingly. The key is to believe the data, ensure the data has integrity, and then to respond from that.
I'm beginning to get the impression the motto is do it once, do it right. Yeah.
Well, it has to be.
Yeah.
Once, do it safe, do it right.
Yeah. Okay. Great stuff. All right. Well, just to move over to something that you can talk to, Erik. Hardware in the loop testing. I hear a lot about this. It's something that's gaining more and more importance in all types of testing. I wonder, could you just talk through what it is and talk about what it is in context of flight testing?
Sure. So hardware in the loop would be taking any piece of the system within an airframe, whether it's a flight control computer, whether it's a single piece of avionics, whether it's a certain sensor, putting it on the ground and testing it within the system through all the various scenarios that piece of hardware might see up in flight. And so if you need to simulate various signals going to it, you've got that ability. It's got to be a high fidelity type of simulation versus a test. The difference between test and hardware in the loop, test tends to look at single points along the way. Hardware in the loop is a nice long analog signal going from 0 to max and even the negative endpoints. And so you want to be able to efficiently set up your systems and run them through all the different scenarios, even the failure modes, and make sure it's going to work. We've seen typically that there is a simulator, a flight simulator attached to these, so the pilot can come and fly the entire system on the ground and run through every single aspect of a flight on the ground and ensure everything is working.
Okay, great. It's yeah. I mean, I can see the questions are coming in thick and fast now. So I'll just ask one or two of mine. I really wanted to ask about certification and regulators. Obviously, such an important part of what you do. I mean, can you describe how you approach that, how you work with regulators? You always obviously aim to have a successful, productive relationship, I guess. But I mean, is there anything you can share with us about the best way to do it?
Is that for me, Ben?
Why not, Tom? Yeah.
So sure. I mean, we're heavily engaged with the regulators, whether it be Transport Canada or the FAA and even EASA. You know, it starts with being competent and having a thorough comprehension and knowledge of the requirements that you have to meet, and whether going through the process of issue papers and CREs and those to develop an excellent plan, a plan that's based upon data and engineering principles. It has to be the foundation with which you engage the regulators. And after you establish that, engaging and being transparent and being open and clear and engaging them as partners in the process, not necessarily asking them all the time, you're allowed to do, but making solid proposals and justifications, again, based upon engineering principles. If we stay steeped in the information, the regulations, and how to meet those requirements, clear understanding of the requirements, it's an excellent foundation for how you can have a great relationship and a respectful relationship between the two parties. And transparency will always be the best approach, and engaging them in that manner.
Okay, great. Erik, anything to say to that? Do you get involved with that side of stuff at all?
We don't necessarily with the regulatory bodies. We depend on our partners like Bombardier to be that interface. Again, we supply the tools. Yeah.
Okay, great. Okay, well, let's move on to the next part. I don't know if you guys can see the poll results there as well. The question was, what are the most important management skills to have to run an effective flight test program? I don't know if there's any surprises in there for anybody. Being flexible and being resourceful is just about tips the balance as the most important skill to have. Does that surprise you guys? Would you agree with that? You've got to be flexible and resourceful, or everything falls apart?
Well, I think I absolutely believe that you got to be adaptable and flexible. You also have to have the courage to say no and to proceed in a sure manner. I do think that's important. Again, if safety is your top priority, you have to be able to deliver some of those less than palatable decisions. Sometimes maybe schedule does delay. Maybe you have to take a breath and reassess. You have to be able to do that in our business because the safety component is such an immense part of it.
Planning as well up there as being important. Nobody likes budgeting much, though. By the looks of things, I guess that's not a surprise.
No, but people dislike surprises more than those things. So planning to eliminate surprises is certainly important.
Okay, great. Okay, so we've got some questions here. I'll just run through from the top. I've got one here from Hunter Block. He wants to know, how do you track a requirement for test or data from beginning to end? Do you have a large database that takes requirements from design engineering and the aviation authority and tracks it all the way through to test execution and completion? Or is it several systems that work together? I guess that's you, Tom.
Yeah, so ARP 4754 has brought in the requirements. We certified our 7500 under the ARP requirements management system. We do have some tools. I won't necessarily advertise those tools, but there's several out there. And it starts with establishing the requirements in a compliance basis, and ARP requires you to then track the progression of validation of those compliances all the way to the artifacts that conclude with data and information in that finding of compliance. So that has certainly brought in a rigor that I think as an industry we applied at the aircraft level and somewhat at the systems level, but it's even going down into much lower level of detail and fidelity with the onset of that ARP requirement.
Okay, great. Erik, have you got any comment on that? No.
I do not.
No. Okay. I've got one here from Jason Radford that maybe you might want to talk about. he wants to know about EMI, EMC interference between flight systems and DAC. Does instrumenting for flight test ever change the characteristics of an aircraft?
That's a really good question. I can't comment on changing the characteristics of the aircraft per se. We certainly, as hardware providers, have to show that our hardware does not emit all these various frequencies at any decent level, so that it does interfere. We ensure that it doesn't interfere. We have various tests we have to pass, whether it's DO-160, whether it's the military 461. That, again, if our hardware doesn't pass it, it doesn't go up.
Okay, sure. I think, Tom, you sort of talked around that a little bit during the Q&A before, didn't you? So we'll just skip on to the next one. This is quite an interesting one from Arturo Trevino, who wants to know, what kind of academic backgrounds and experience do you look for in flight test team members? How do you get into it?
Well, it depends upon the specific areas of interest, whether it's an engineer or a technician or a pilot or an FTE. Certainly, our DER and DAD pilots, many of them have progressed up through various levels of responsibility and ranks within the business aircraft community. So many of them obviously come out of the military test pilot schools. So there is ways to get there. There's multiple paths to get there, whether it's through the test pilot school or cutting your teeth and progressing through the ranks from an engineer to an FTE to a chief pilot. FTEs can take similar paths. There's certainly aviation schools that allow people to have a jump start if the FTE responsibility is one that you desire. Going through the military, we have a mixed bag of all that you can achieve the knowledge and the credits, credibility and capabilities to enter into those positions. We have a lot of, because we're remotely located from our primary offices in Montreal, we have a lot of design engineers that work in flight testing. It's due to the nature of what we do, it's a highly variable activity. So people find it really interesting to work at an aircraft level to do the test diagnosis and engineering testing itself. And then a lot of our A&P mechanics and the individuals that manufacture the parts or maintain the airplanes, they predominantly have A&Ps, but we have experimental individuals that come out of, again, the military academies or go through some of the tech schools. In Wichita here, we have a quite aggressive relationship with the local university, Wichita State University, that sponsors some of those technician training and their ability to achieve those credentials to support things like experimental. Unlike airplanes, experimental installations have some novelties to them that requires those specific training. And with the onset of all the new technology, so that new training and that keeping up with the latest technology is ever increasingly important. So you can get academically through the military or some on the job, but it's always good to start with a foundation of knowledge from military or academics.
I guess set your aim and once you know that, go for it. Okay, I'm gonna change the pace slightly with this question for you, Erik. It's from Ishmael Bitoon. He wants to know, slightly more technical, how do you cope with the lower bound of the accuracy of test instrumentation with the accuracy of test data needed for simulation validation? Does that make sense to you?
It doesn't, and it doesn't. So we ensure that many of our simulation interfaces are very high fidelity to match the accuracy requirements needed. We have had customers, again, want to test at fixed points, but all of our simulation interfaces are all throughout the range. And we work hard at using the most precise circuitry we can on the market to ensure that we are giving our customers the most high fidelity signals for their HIL testing. It's a great question because it certainly can be a problem.
Okay, great. Okay, thank you. I've got quite an interesting one here from Oliver K. He wants to know, Tom, probably one for you. How do you monitor compliance following initial certification? Do you continue to monitor compliance following certification? Do you, for example, record data from production aircraft and use that? Are you doing that yet?
Well, not from a certification monitoring standpoint. Certainly, the expectation for FDRs has increased the level of data that's recorded on an ongoing basis. That's typically not downloaded unless it's event driven. From an overall airplane standpoint, though, there's been a tremendous pursuit of health monitoring systems, on aircraft health monitoring systems. So as a manufacturer, we can monitor and collect information. Certainly, this is a huge growth area that we expect to pursue more, because the more I know about how that airplane is operated, what's going on with that airplane, the better the product that I can either provide to the customers, or that I can unforeseen events. So I think the pursuit will be dual. The use of that data and information on these health monitoring systems will allow you to certainly provide some oversight and capabilities to monitor system performance and design performance. And some of that is in place. Certainly with the 7500, we've done that. But again, all that data, which will be a huge amount, allows you to better understand your customer and to provide him the airplane he actually uses and what he's using it for.
Okay, great. Erik, you do some of that as well, don't you? Health monitoring systems.
Yeah, certainly. So we do retroactively add in health and usage monitoring systems. We call them HUM systems onto Bombardier C-Series jets, onto U.S. Air Force Huey helicopters. And yes, we have found both the manufacturers use the data, as well as, for instance, the owners of some of the private jets, so they know what to maintain and when. And you're right, it is a huge amount of data. So typically these are event monitors waiting for events, and then it would record the information both pre-event and post-event for analysis after the fact. We also see it as a nice market.
Sure. I mean, this is perhaps quite a nice follow-on question then, if someone wants to take it, from Mir Ali, who wants to know about data science. Quite a buzzy word, I guess, data scientists, data science. But are you incorporating that into what you're doing at the moment with the test data that you get? With you, Tom or Erik, use data scientists at all?
Data sciences?
Yes.
As in AI?
Well,
like that?
Somebody that's analyzing the data, looking for trends and just looking exclusively at the data all the time.
Yeah, I don't believe that's a novelty or a new activity. Since the day we started collecting data, there's ongoing use of that data in monitoring and oversight and interrogation. It's the crux of some of the more ingenious things that the engineers bring to the table when they're as a result of the testing, you produce all this data. So analyzing it and truly understanding what that data is telling you. If that's the crux of the question, then yes, it's an ongoing and extremely important part of the activity with respect to what you do with the data after it's produced.
But not something new in flight test, right? Certainly not.
Yeah, we certainly see it in the health and usage monitoring realm as well, to do predictive maintenance. Okay. We have some of our customers, I'm not sure it's artificial intelligence, but they call them their AI systems. So certainly the application of the latest trends are being applied.
Okay, here's a question from Francesco Marullo, who wants to ask about flight flutter testing. He wants to know, do you ask a question about flight flutter testing, mainly for the excitation system or devices used? Is that a question? I'm not sure it is really. Let's skip for that. Okay. How about this one here from Oliver K? Have you seen a shift in the roles of flight test engineers and pilots since the earliest programs that you were involved with? Tom, do you want to take that one first, and then maybe Erik?
Have we seen a shift in the role of flight test engineers and pilots over the years? Sorry, there was talking over. Well, there's certainly an evolution of expectation. With the integrated airplanes, pilots have a higher level of demand on their abilities to carry out the capability. We have to remember, I have what I would describe. I don't have pilots. I have engineering test pilots. So these individuals, as a member of the engineering compliance team, have a responsibility as an engineer, not only to fly the airplane, but to be an integral part of that finding. So the higher level of complexity of the systems, I think there's been a proliferation of maybe a little bit more specialization sometimes that people with at least on a program where they'll focus on the systems aspects or the aerodynamic aspects of the airplane. There's so much testing and so much complexity that you really need that focus that typically can occur throughout the certification of a clean sheet airplane to allow that individual to have the knowledge and ability to fully envelop themselves in that discipline. But, you know, planes are planes, you know, the complexities go up, the type of information you record goes up, but we're still flying airplanes at higher, faster levels. And some of certainly the basics, they're still there. The data itself has increased tremendously, qualitative assessments and those type of elements play a much lower part as opposed to the actual data that you collect.
Okay, I've got one here from Stuart Watson. This one about Flutter does make a bit more sense. Can Flutter performance be realistically simulated before actually flying the test aircraft? Can you do that? Or
not everywhere. So there's a reason, and we certainly pursued to the highest level possible through simulation and analysis. But there are certain dynamic regions that you still, the FAA and the regulatory authorities still expect you, because of the very nature of those regimes, to go out and demonstrate it. Will it improve? It may improve in the future, but today there are still regimes that I've got to go demonstrate that testing on in an airplane. Make no mistake, there's still a show me tendency, right? As good as we get with simulations, as good as we get with simulators, they've evolved to dynamic characteristics that you can do within simulators, but there's still an expectation to show me.
Okay. Does that enter what you do at all, Erik, Flutter, or do you have to test for that with the avionics on the ground? Can you do that?
Can you do it? It all comes down to the fidelity of the simulation and actually getting real data and then feeding it back into the simulation. And to Tom's point, a lot of it is they just want to see it.
Okay, sure. Okay, so I'm going to pick another question now. This one's about NDT, actually. Where do you see non-destructive testing within the certification process? And is there room for any new NDT technology within it? That's from Laura Mabry. Is that something that touches you guys' worlds at all? I'm not sure it does. No.
Well, I mean, I guess I'm not sure how we would expand upon it. I'm not sure I could give you a full and thorough answer on that from my perspective. NDT is still a reality. It's more in the ISTCR and the ground rigs and the aircraft test rigs for structures testing. But I don't marketably different pursuits in that area.
Okay. Let's ask this one from Juan Segal. What impacts are you seeing, or do you think you might see in the future, on flight test programs in a post 737 MAX regulatory environment for clean sheet or major retrofit programs? I mean, it's a decent question to ask how you think it's going to affect what you do. It's obviously a big deal. We had the news yesterday about the 737 MAX. Do you think how's it going to impact on what you guys do?
So theoretically, you'd say none, but the reality is there's a higher level of scrutiny and oversight that you may be applied. I don't think in the beginning, because we negotiate levels of involvement and oversight. But if you're trying to be transparent, this is fine. There may be an increased amount of flying that we need to do to show regulators. That's okay. I believe that when you collect data that's definitive, that as long as it has integrity and you ensure that, then that should be adequate in many cases. But again, the show me principle is still there. One element we haven't discussed today is the whole work from home and the difficulty. I know the 737 guys had to go through some challenging hoops to regulators, could attend, could participate, and witness that testing. So I think we'll all be glad when we're at a point where we can more readily engage on these things and support the expectations at the higher levels that I expect regulators will apply. And that's okay, because we want to be safe first. So.
Okay. Erik, any comment on that, on how 737 MAX is affecting what you do? Maybe not.
I would just guess that there's going to be more testing, which means people need more flight time, more hardware, more data to analyze.
Okay. So maybe time for just a couple more questions. We did start late. I'm conscious of that, but let's ask this one here from James Day, who uses a term that I'm not very familiar with, actually, or not familiar with at all. He wants to know, how does the development of more certification by analysis impact the flight test instrumentation and approach? Certification by analysis. Familiar with that?
Well, certainly we're always pursuing the highest level of credit that we can obtain via analysis and simulation and things like that. In the end, you have to close the loop. You have to validate either your simulations or your analytical assumptions. You have to still collect enough data to show that those assumptions and those methodologies that you apply through analysis have credibility. So you're still going to collect data. You're still going to validate your modeling and that are used to show compliance through analysis.
Okay, sure. I've got one here from Ralph Brilhart, who's asking about fiber optic sensors. He says, with the increased amount available, of fiber optic sensors, is there a movement towards embedded systems that cover ground flight and HUMS data collection? Anybody on that?
Erik, I'll let you have it.
Yeah, I'm actually reading the question. With increased fiber optic sensors available. Well, yes, that's kind of exactly what we're seeing. Although I'm not sure what fiber optic sensors have to do with it. Yes, we are seeing our customers taking the hardware on the ground and flying it, whether it's a flying test bed, they call it, for a certain component, whether it's an engine or a piece of avionics, or actually a new flight control computer with a new kind of control scheme. Certainly, we are seeing that.
Sure, good stuff. Okay, all right. So I think perhaps we'll draw it to a close there, guys. It's a real mixture of questions there. I think we covered a lot of ground. It's such a broad subject area. We've talked about lots of different very specific technologies, and also taken a very top-down approach as well at the same time. So I hope it hasn't spun people out too much, really, that approach. I don't know if there's anything you guys would like to add. Tom, first.
Well, I really appreciate the opportunity. It's some really good questions and interesting one-way dialogue, I guess you'd say. We still have the passion in our industry, and it really intrigues. And for me, did I ever expect to be and do the things I've done? Probably not all of them, but what a great industry we have that fuels your fire and captivates you. And again, as long as we maintain that safety and we produce the products we can be proud of, I think we have a great industry, and the testing and the things we do, I'm certainly happy to be a part of it.
Great. Erik, any closing remarks?
Yeah, thanks, Tom and Ben. This has been great, and yes, I agree with the technology. It's amazing to see space flight. It's amazing to see new airframes. It's amazing to see small drones running around. It's great to see electrification. All of this is pushing the envelope, and it keeps all of us employed. What can I say?
Yeah, me too. All right. Okay. Well, just
exactly.
Yeah, just okay. So just to sum up, then, I mean, this roundtable will be available to view again afterwards, almost immediately afterwards, via the Aerospace Testing website. So all that remains for me to say is thank you, Tom, and thank you, Erik, and thank you everybody for turning up and tuning in and participating and filling out the poll and the questions. It's really been an interesting hour. So thank you again. Cheers. Bye bye. Take care.
Cheers.